Hello everyone, welcome to today's flash drill discussion session with me, Shreyas, your master teacher for physics. Like you all know, flash drills are nothing but assignments which you get daily after every session, and when we have completed some significant chunk of that topic, we give you assignment in the description box as well as the Telegram group, and you have to solve them, and we are going to discuss all the questions very neatly and very carefully out here. So that's the advantage that you have in our flash series, and that is what we strive for at JEE Enthuse. We want to deliver the best. We want to give you the best of the questions. We want to prepare you right from the simple to the hard questions, because now there are people at probably this level who have this much of understanding. Some people have more understanding. We want everybody to reach here, and then we are going to scale it up. All right, so guys, please help each other. I know this is a recorded session, so I might not be able to answer your chats, but all the JEE enthusiasts who are our members of our family, get in more members, help each other in the chat box, motivate everyone, and you have to make this family grow stronger and bigger. All right, so in case you have forgotten the schedule for this week, so we have started with integration. In case you have not watched that video, please watch it. And then Newton's laws and pulleys, that multiple pulley problems, string problems, that's what we did in the last few days, and that is what we are going to discuss today. And then we are going to go to non-inertial frames and the frictional force. That's the schedule for this week. And in case you're not forgotten, if you're just forgotten to subscribe or like, please do that right now, because if you do not subscribe or like the video, then YouTube algorithm will not show you our videos, and you might miss out on some amazing videos out here. So do not forget to subscribe as well as like the video. All right, so having said that, let's start with our discussion. Now the first question is a tricky one, because a lot of English out here. Which of the following cannot be true? An object experiences no acceleration. So it's little confusing at the start, but you get the hang of it in a while. So here is the thing. When the object experiences no acceleration, let's write down what is given. Zero acceleration. So if acceleration is zero, what does it mean? There are multiple options. Option 1, there is that mass and there is no force only acting on it. So there might be no force acting on it. That's one option. Second option is that mass is there, there are forces, but they balance each other. So if they balance each other, then also the acceleration is zero. So both options are possible. So it's an or. Now let's decide based on this. A single force acts on the object. Think about it. If a single force acts on the object, who will balance it? Nobody. So will this be true? No, this will be false. So this is false, or I can say this is wrong. Okay, so this is wrong. No force acts on the object. Well, it is possible. You can see that no force acts on the body if acceleration is zero. So hence this is correct. Forces act on the object, but they cancel. Yes, that is also possible. And none of these, well, that is ruled out now. So hence, which of the following cannot be true for the object? That is option A. If all of them were true, then you would mark none of the above. But right now, we have at least one option which is not true. So hence, option A should be the correct answer. All right. So that is option A, which is correct. I hope you guys have understood it. Let's go to the next question, which is going to come up on your screen. Now, penguins being pulled by some force. Let's try and solve this. So how do we do that? Now there are many ways in which you can do this, but the easiest way is as follows. Masses are given. Okay, the masses of the penguins are given. Force applied is also given. So first thing that I will do is take the entire penguin plus the ropes connecting them as a system. So consider it as a system. So what will be the mass of such a system? Each penguin's mass is 10 kg. So 10 plus 10 plus 10. How much is it? 30 kg. So that is the mass of my system. There is no friction. but there is only one horizontal force. And how much is that force? Is it given to me? I think so. Yeah, that force is 60 Newton. So 60 Newton is 30 multiplied by acceleration. There is no friction, no other horizontal force. So that's an easy way of doing it. So acceleration is 2 meters per second square. So easily, very quickly, I have found the acceleration of all the penguins A, B and C. Once I find the acceleration, I can easily find the tensions. How? Let me show you. Let's take the penguin number C. So this is penguin number C. Okay. What are the forces acting on the penguin C? Think about it. Well, there is one tension. What is the tension called? TBC. Nothing else apart from tension BC acts horizontally. Weight and normal are vertical, so just ignore it. Forget it. Friction is not there. And it has some acceleration. How much is it? We just figured it out. It was 2 meters per second square. That's it. So using Newton's laws, TBC will be mass, which is 10 multiplied by acceleration. So that will be 20 Newton. That's the answer. Similarly, go to penguin number B. Okay, what are the forces acting on it? Well, a tension force from here. Why? Because there is a thread connecting here. That thread will pull both the penguins like this. This same thread between B and C will pull C this way, but it will pull B this way. That's why tension BC will be this way. And the thread between A and B will pull it that way. That is tension AB. And it will also have some acceleration of 2. That's given. Weight, friction, normal will not be there or will not matter. Now, TBC is already known. We just figured it out. So use that over here. So I can say TAB minus TBC is 20 is equal to mass. What's the mass? That's 10 into acceleration. So therefore TAB, you can check it out. 10 into 2, 20, 20 plus 20, 40. So that's 40 Newton. That's the answer. Similarly, do the same thing for anything else. Oh no, that's it, done. 2 tensions, that's what we are asked. There is no third tension. That third tension is the force itself. Okay, so if there was a tension here and if it was asked, then the answer will be F itself. Okay, but that is not asked, so don't worry. So that is the answer, 20, 40 and 2. So I hope this is clear. 20 Newton, 40 Newton and 2 meters per second square. Very easy. All right. I hope you guys have understood. And please help each other in case some queries, doubts have been asked. All right. That's what we enthusiasts are for. I want this family to be very strong, very motivated, very aligned to our thoughts, our principles, our vision. Okay. So let's go ahead to the next question. This is a slightly tricky question because I've seen many people get fooled by this question. Why? I'll tell you. So imagine, okay, just one second. If I draw the FBD of this system, well, there is that weight and all that of this guy. And how much is this weight? A block of 5 kg hangs and 2 kg is on the table. So this is 2G. And yes, there is a normal. Let's say I call it N1. And here you will have some tension. And here also you will have some tension. And here you will have 5G. Now, this is the forces. These are the forces. But where will it accelerate? A lot of people think since I'm pulling it here, so it will accelerate this way. Think again. Think again. Use the opening up method. Things will become very simple. In case you're new for this channel, what is opening up method has been taught in the earlier session when I discussed pulleys and strings. Yes. So I will just open it up and simultaneously also rotate the forces. And that system will look something like this. This is that pulley. This is that mass of 2 kg. And this 5 kg will go there. And believe me, this pulley won't even matter anymore. And then you just have that 1 Newton force from here. And from here, you have 5G force. So what is this 5G force? Think about it. It's 50 Newton. Think about it. This is 50 Newton. Yes. Which force is more, 50 or 1? Obviously 50. So where will it move? Left or right? Obviously right. So understand guys, this 5 will move this way, and that's why this 2 will also move this way. That's why this block will move this way and this block will move down. Yeah, this force is not sufficient to bring it up. It is acting, but it is getting dragged. That's what is happening. Okay, now it's simple. What is the acceleration? The acceleration is the net force 50, which is bigger, minus smaller, which is 1, divided by total mass, which is 2 plus 5. So 49 by 7, that's 7 meters per 7 square. 7 meters per second square. That's it. That's the answer. That's the acceleration. And last question, tension. Oh, that's not difficult. We have already drawn so many FBDs. You draw, you take any one block, either this block or this block, it doesn't matter. Let's say I take this block. Okay, so for which kg block is 2 kg block. So for the 2 kg block, this is how my equations will look like. It's going that way, right? So T minus F will be M into A. So just use whatever the values are there. T is unknown, sorry. F is 1. What is M? M is 2. A, I just found out 7. So therefore, T will be 7 to the 14 plus 1, 15. So 15 Newton is the answer. So that's how you do this question. I hope it is clear. Yeah, interesting. A lot of people get fooled into thinking it will go there, and a lot of sign convention mistakes happen in this problem. That's what I've generally seen. Okay, no problems. That was the answer for this particular question, 7 meters per second square and 15 Newton. Let's go ahead to the next question. This was also an interesting question. This person is sliding down that rod and there is some friction, there is some force which the pole is applying on that person. That is the reason why he is not sliding down with 10 meters per second square. He is sliding down with 4. Why? Because of some resistive force. So the question is, what is the force by the firefighter on the pole and by the pole on the firefighter? Both kind of questions are there. So let's see how do we do this particular question. So first, think about the forces acting on the firefighter. What kind of forces will be there? One will be his own weight. How much is his weight? Oh, he weighs 700 Newton. So the weight itself is 700 Newton. That's given to us. His acceleration, that is 4 meters per second square. So let me write it down. Acceleration is 4 meters per second square. What is the force and direction on the firefighter from the pole? Obviously, since this is less than 10, the force on the firefighter by the pole on his hands must be upwards. So that is the force acting on him. Now, what do? That's it. Our job is done. We have drawn the free body diagram of the firefighter. So let's write down Newton's law equation. So that will be weight minus force will be mass into acceleration. What is the weight? It's 700 Newton. What is the force? That's something I have to find. What is the mass? Think about it. Since weight is 700 Newton, that is mg. So obviously m will be 70 kg. Think about it. So just substitute 70. And what is acceleration? Well, that is 4. Therefore, F will be equal to 700 minus 7 4s are 28. So it is 280. So this will, yeah, I hope this is fine. Yeah. So F will become, think about it. Yeah, 420 Newton. That's the answer. So whatever force is applied on the firefighter, the same force the firefighter will also apply on the pole. Why? Because Newton's third law. So by third law, force on the pole by the firefighter will be the force on the firefighter by the pole, magnitude wise, obviously. So that's the answer for this particular question. 420 Newton upwards on the firefighter, 420 Newton downwards on the pole. Action, reaction. They are action-reaction pairs, so that's why they are equal in magnitude but opposite in direction. This was also an interesting question. I have solved a quite similar problem in my regular session if you have seen it before, and you will see the similarities in both the questions. So in case you are new, again I'll remind you to please subscribe, like, so that you do not miss all these important pointers out there. So what would be the tension due to its own weight as a function of height when suspended? Mass is m, length is l. Okay. Now first of all, this is a rope or a string with mass, so because of which it will have tension because of its own weight. Alright, so think about it. Where will the tension be more? Where will the tension be less? Think of one person holding the other. Let's say you are hanging from a tree, somebody is holding your leg, somebody is holding your leg, and somebody is holding their leg. Who will be under more tension? The bottommost or the uppermost? Obviously the uppermost. So the uppermost person will have to support the entire weight. The lowermost person is chill, he just has to support his own weight. So the tension will be very small over there, and it will slowly go up as you go up the string. So that's why the tension is variable. If you understand this, let's go ahead and let's choose a small part of the chain or the string or the rope, and let's start assuming things. First, let's assume that the part of the string which has been chosen is x. The mass is small m, but the actual length of the string is L, and the entire mass is capital M, or I think it is given as small m. Okay, so then this mass will be something else. What would it be? Let's figure it out. I'll need it for solving problems. Now, since the rope or the chain is uniform, mass per unit length is the same. So use unitary method and you will get the answer. For a length of L, the mass is m. So for a length of x, how much is that mass? Think about it. It's not that difficult. The mass per unit length is m by L, and into the length will give you the mass of this part. Or you just use ratio proportions, you'll get it. It's not that difficult. I want you to think about this on your own because this is a 8th standard problem, not more than that. So it will be nothing but m x by L. That is the answer. That's the mass of this part. That's the mass of this part. Great. Why do I need it? I'll tell you. Just one sec. This is the mass of this part. Why do I need it? Well, if I draw the free body diagram of this part, think what and all forces will be there. Wherever I have cut it, hypothetically, not physically, there will be a tension acting upwards. And do not forget, there will be also its own weight. And that weight, will be balancing the tension. Reason, that element is at rest. So it is at rest, hence net force should be 0, hence tension minus weight should be 0, therefore tension should be equal to the weight. And what is the weight? Mass, which is mx by L into g, and that is the answer. If you want to write it a little bit neatly, so it will be mg by L into x. So you can see tension changes with x. When x is 0, that is when you are here, the tension is also 0 because it is not supporting anything. And when x is L, that is when you go here, LL cancels, you will get it as mg because it has to support the entire weight of the string. I hope this is fine. So that's why this is a very good question. How to solve problems where mass is involved in the string. Very nice question. So that was the answer for this particular question. Now this is also a very interesting question. A lot of people think that this is a constrained motion problem. But if you notice carefully, none of the pulleys are moving. Yes, observe. This pulley is fixed. This pulley is also fixed. In fact, it's so simple that if this mass moves some distance, even that mass will also move the same distance. It's not A, 2A, A, 3A, nothing. You can also do it by my method which I gave yesterday, the shortcut trick. The tension on this is T and the same string is connected here. Tension is also T. So if T and T act, accelerations will also be A and A. That's the trick which I gave in the previous session. So what to do? Well, let's read the question. The question is find the reaction on the pulley. Okay. Now to find the reaction on the pulley, believe me, you need to find the tension. Only then you can do that. And how do you find the tension? Well, you have to find the acceleration first and then you have to go ahead about it. So let's do the usual basics first, find tension and then find and look at the free body diagram of that pulley. Now, if that mass was here before, it will move like this and it will supply the string. It will supply the string here and the mass will come down. So if this mass moves by X, the string supplied is X, this mass also comes down by X. Do not forget that. Okay, so keeping that in mind, let's do this. If the acceleration of M is A, this mass also has the same acceleration. Next, what do I do? Okay, this mass is going to experience some tension. That's it. The weight and the normal will not matter, so don't worry about it. This is one string, so the tension remains the same. And on this mass as well, you have the same tension, but there is this mg down. So for this mass, my equation will look like T is equal to, or if I write here, T will be equal to ma. That's my equation for this mass. For this mass, it will look like this. mg minus T is equal to ma. mg down, T up is equal to ma. So just substitute this T in the second equation. I think you'll get the answer. mg minus ma is equal to ma. Therefore, mg is equal to 2ma. Therefore, A is equal to G by 2. Once I get A, I will also get T. So from equation 1, I will get tension is equal to how much? mg by 2. Is the mass given? Yes, 1 kg. G is 10. So it will become 1 into 10 divided by 2, which is nothing but 5 newtons. Okay. Now what? Now what do we do? Here is the thing. Think about the free body diagram of the pulley. That pulley is being pulled by the strings like this. So the tension will be acting in these ways, T here and also T here. Same thread. It's pulling it from both sides. Now the resultant of these two tensions will be here. Think about it. This T and that T will pull it here. So to balance that, this table will have to push it that way. So that's the reaction. I hope this is clear. So these three together cancel out each other because the pulley is light. So don't worry about the mass of the pulley. So don't have to worry about it. This tension will produce a resultant here that will be cancelled by that R over there. So isn't it obvious that the resultant, where did it go? So yeah, resultant of T and T, which are perpendicular to each other, balances the R force over there. So what is the resultant of T and T? Oh, they are perpendicular. So what's the resultant? Think about it. That's obvious. It is T square plus T square root. That should be equal to R. And now it's simple. T is 5 Newton. So it will become 5 square plus 5 squares root is R. So that will become 5 root 2 newtons is equal to R. That is the final answer. So the reaction experienced by this pulley is, yes, 5√2 Newton. This tension will be resultant here. So exactly opposite. In fact, this angle will be 45 degrees by symmetry. Think about it. Okay? Great. What an amazing question. I'm pretty sure you're learning a lot. 5√2 Newton. Now, let's go to the last question, which is also a very good question. Masses are given. This question is there so many places, but I feel that we should discuss it. That's why I'm doing it here. The question is, what is the acceleration of the blocks? So I'm just going to give you the equations, because problem is getting those equations, and I know a lot of people face difficulty in that. So don't worry, I'm here, I'm going to help you out. First things first, pulleys are massless. Okay, keep that in mind. I'm going to draw the FBD here only to save some space, because we're going to need it for sure. Okay, now let's think about the free body diagrams. Please understand, I have not yet taught what is an inertial and a non-inertial frame. So I will not be using any pseudo forces. I'll be sitting on the ground and making all the observations. Yes. So let's do this. This is going to be M1. M1 is 1 kg, M2 is 2 kg, good, and M3 is 3 kg. So this is just going to be 1 G, or basically just 10 newtons. Okay, so this is just 10 newtons. There will be some tension here, and that same tension will be acting over here. So on this pulley, think about it, the same tension will act. Yes, the same tension will act. And that tension will be divided into two parts. We have done this before. So understand, if each of them is T and T, this should be 2T, and by the same string method, so this should be also 2T. Tension in the same string is always the same. Keep this in mind. If it is light, frictionless, etc., so tension should be same. And why is this T and T and this is 2T? Think about it. This pulley is light, massless. So if mass is 0, think about it. If mass is 0, right? So the force acting on it, net force, should also be 0, because mass into acceleration does not matter once mass is 0. Force should be 0. So these two together should cancel out the 2T force. Great. What next? On this mass, there will be T, there will be 3G, which is 13 Newton. And on this mass, again, there will be T over here, okay? And there will be 2G, which is nothing but 20 Newton. Keep in mind, I have not yet shown the accelerations deliberately, because that's the trickiest part. So observe carefully. I will say that M1 goes up with some acceleration A1. How does it matter? Just assume it. Where is this measured from? Ground. If this goes up, the string goes up, the string falls here, and this pulley comes down. So this pulley, believe me, will come down with the same acceleration A1. Pulley's center will come down with the same acceleration magnitude. Great. Now think this way. Just forget everything else. Just look at this pulley, M3 and M2. Nothing apart from that. Nothing apart from that. You sit in the pulley frame and then observe the second mass. Yes, and the third mass. It's just like a normal pulley system, because you are sitting over here. Visualize, all this diagram should be erased from your mind. So M2 is going up, M3 is coming down. Wouldn't their accelerations be same? Yes, of course. So M2 will be moving up with respect to the pulley. Assume it to be A. Assume it to be A. If M2 relative to the pulley comes up and the pulley comes down with A1, think about it. How much effectively did M2 move? Now that's the problem, guys. See, a lot of people are not able to visualize this. See, from the pulley frame, this block M2 went up. Okay? How much? A. But this entire thing also came down, na? Because this pulley came down with A1. So it went up by A, but it also came down by A1 because the pulley came down by A1. So how much did it effectively move? Think about it. A1 minus A. This is something you should understand. Okay? Now you will be like, sir, how do you know A1 is more? Well, I don't know. I'm assuming. If I'm wrong, the answer will come out to be negative. You don't have to worry about it. In fact, in the previous session, we have solved one question where the answer came out to be negative and I deliberately did that. So you assume something to be more than the other thing. I'm assuming the pulley falls more than this M2 going up. So it's A1 minus A. Great. So actually speaking, understand this M2, I'm using blue color deliberately. Okay, moves up by A. This is with respect to the pulley, not with respect to the ground, but actually speaking, it has come down. Okay, actually speaking, it has come down by A1 minus A. Please understand that. Okay, so it has actually come down by A1 minus A. Okay, so get that thing straight. Okay, now if you have understood that part, let's go to the next part. What about block 3? Again, sit on the pulley. You will see block 2 going up, block 3 going down. Block 3 will go down with acceleration A, down, same, with respect to that pulley. So whatever acceleration this comes up, this will go down by the same acceleration. Now here is the thing. If you are sitting on that pulley, for you that block 3 will go down by how much? A. But do not forget the pulley is also coming down. So because of which the block will further come down. So how much will be the total acceleration? It will be A plus A1. I'll repeat again. This block came down by A with respect to the pulley. All right. Do not forget, even the pulley came down by A1. So this block will go further down by A1 with respect to the ground. That's it. So it will be A plus A1. That's the logic behind it. And that's why if this M3 goes down with acceleration A, again, with respect to pulley, strictly speaking, it has gone down by acceleration A plus A1. Yes, that's the acceleration with which it has gone down. So the concept of relative motion is used here, isn't it? Now, I know the diagram looks very colorful. I hope you are not confused. And it's so interesting to solve this problem. Now let's just write the equation, because after that it's just a matter of solving those equations, which any kid can do. But getting till here is the physics part. After this is maths that anybody can do if you know how to solve those maths equations. Let's see what those equations look like. Now here also be careful. Okay, let's start with M1 first. Starting with, oh my god, don't tell me it's stuck. Wow, okay. Okay, somehow managed. So let's start with M1 first. So for M1, the equation will be 2t is higher, 10 is lower because it is going up. Okay, so 2t minus 10 is equal to M1 is 1 kg, so 1 into A1, that's it. So A1 is equal to 2t minus 10. That's equation number 1. Great. Next, for M2, what will be my equation? M2 is here. It is accelerating down. Look at that. A1 minus A. I hope you can see that. So if it is accelerating down, this should be bigger force. This should be smaller force according to our convention. That's it. So it should be 20 minus T. Right? Do not forget, that this is all with respect to the ground. Yeah, it might be going up with respect to the pulley, but that doesn't matter. For me, on the ground frame, this is actually going down. So 20 is more than T. That's it. That's not negotiable. So 20 minus T is equal to 2 into A, 1 minus A. That's what I'll write. Okay. Can I do something more? I don't think so. I'll just put it as equation number 2. And then M3, how much will it be? M3, think about it, M3. Where is it moving? Down. Okay, good. So 30 is more than T. So 30 minus T is equal to mass, which is 3, into acceleration, which is A plus A1. That's equation number 3. Count the number of equations you have. 1, 2, 3. Count the number of variables you have. A, A1, T. 3 equations, 3 unknowns, solvable. That's it. You use your techniques however you want to solve it. It's up to you. I can give you some ideas, like you can add both of them and then add that to this. So you can clearly see 2T minus T will get cancelled out. You'll get some equation in A1 and A, solve it, eliminating time, and so on and so forth. It's up to you how you want to solve it. You can also eliminate T from this side. You can just flip it, flip the equation and then add them. Again, time will be eliminated. Solve it. It's not that difficult. So solve these equations. It's up to you how you want to do it. It's an open, it's an open game, guys. It's up to you. Okay. But I'm pretty sure that's not the difficult part. So after solving, these are the answers that you get. 19G by 29 up, 17G by 29 down, and 21G by 29 again down. Okay, so that is the answer. What an amazing question. What an amazing question, है ना? I'm pretty sure you have loved this session, and do not forget to keep attending these sessions. And if you want to stay updated, do not forget to join the Telegram group, where we not only post all the updates if, let's say, a class is getting rescheduled or something, you know, all that updates come on the Telegram group. Sometimes I give you homework questions, and sometimes I also give you the solutions in the Telegram group. Also the session notes, extracts, everything comes on the Telegram group. Understand? All right. So this is our official Telegram group. And if you have enjoyed my discussion today, if you have enjoyed my teaching, please do not forget to like this video. And if you're a new student, do not forget to subscribe for more such amazing sessions with me. And please, guys, do not forget to share with your friends so that we can make this family grow bigger and bigger. All right. So that's it for today. Have a good day. Have an amazing time. I hope I'll keep seeing you again and again. Bye bye. Take care. See you. This was Shreyas signing off from the Vedantu studios at Bangalore. Bye bye.